Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Maths Chapter 1 Patterns in Mathematics. What is mathematics? Mathematics is in large part the search for patterns and for the explanations as to why those patterns exist. Mathematics is fundamentally about the search for patterns. It also deals with the explanations regarding why those patterns exist. So, what is a pattern in mathematics? A pattern in mathematics is a repeated sequence of numbers, shapes, or objects. It is like a rule that tells you what comes next. This is a pattern. So, pattern is a repeated sequence of numbers, shapes, or objects. Such patterns indeed exist all around us in nature, in our homes and schools, and in the motion of the sun, moon, and stars. So, patterns exist everywhere. You can see patterns in nature. For example, the sunflower. The sunflower is a classic example of a pattern found in nature. Its seeds are arranged in spirals, both clockwise and counterclockwise. We can see patterns in our homes. For example, wall tiles. Wall tiles are often arranged in repeating patterns like squares, rectangles, or hexagons. In schools, your classroom seating is an example of pattern. Here rows of desks are arranged in a grid-like pattern. It is an example of pattern. You can also see patterns in the motion of sun, moon and stars. The sun rises in the east and sets in the west each day. Similarly, the phases of moon from new moon to full moon and then to back. It is a pattern. Then and the position of the sun in the sky changes throughout the day, affecting the length of shadows. It is also a pattern. They occur in everything that we do and see, from shopping and cooking to throwing a ball and playing games to understanding weather patterns and using technology. So, patterns exist everywhere. See, we can say an example for a common weather pattern in many places. It is a daily cycle of sunny mornings, then cloudy afternoons, and potential evening showers. So, all these are patterns. The search for patterns and their explanations can be a fun and creative endeavor. So, searching patterns can be a fun and creative endeavor. Creative endeavor means an activity that involves imagination, originality, and skills to produce something new or unique. That is creative endeavor. So, searching patterns can be fun and creative endeavor. It is for this reason that mathematicians think of mathematics both as an art and as a science. So, mathematicians think of mathematics as both art and science. This year, we hope that you will get a chance to see the creativity and artistry involved in discovering and understanding mathematical patterns. So, in this year, you can discover and understand more mathematical patterns. It is important to keep in mind that mathematics aims to not just find out what patterns exist, but also the explanations for why they exist. So, mathematics aims at finding out what patterns exist. It also gives explanations for why these patterns exist. Such explanations can often then be used in applications well beyond the context in which they were discovered, which can then help to propel humanity forward. So, such explanations can be used in different applications and they can help to propel humanity forward. That means we can contribute to the advancement and progress of humankind. For example, the understanding of patterns in the motion of stars, planets, and their satellites led humankind to develop the theory of gravitation, allowing us to launch our own satellites and send rockets to the moon and to the Mars. Similarly, understanding patterns in genomes has helped in diagnosing and curing diseases, among thousands of other such examples. So, understanding the patterns in the motion of stars, planets, and their satellites helped human beings to develop the theory of gravitation. Do you know what is gravitational force? You will study in science. So, what is gravitational force? It is a invisible pull that exists between any two objects with a mass. That is gravitational force. It is a force that pulls objects towards each other. Imagine you are holding an apple. You let go. What happens? The apple falls to the ground, right? That is gravity. So, gravity is like a giant magnet pulling everything towards the earth. That is gravitation. So, this helps to launch our own satellites and send rockets to the moon and to Mars. Similarly, understanding patterns in genomes helped in diagnosing and curing many diseases. What do you mean by genomes? A genome is a complete set of genetic information in an organism. Genetic information means it is a set of instructions that determines the characteristics of an organisms. These genetic informations, they pass from one generation to another. So, understanding patterns help to diagnose and cure genetic diseases. The next one, figure it out. Can you think of other examples where mathematics help us in our everyday life? Can you say some examples? There are so many examples. For example, in shopping, calculating discounts, total price, etc. Then in cooking, mathematics is used for calculating the ingredients, for measuring the ingredients. Then in time management also, mathematics is used. See, for scheduling appointments, for setting alarms, for managing deadlines. Then in travel, we can calculate the distance, we can calculate the fuel consumption, we can calculate travel time. So, everywhere we can see such examples. Next one, how has mathematics helped propel humanity forward? You might think of examples involving carrying out scientific experiments, running our economy and democracy, building bridges, houses, or other complex structures, making TVs, mobile phones, computers, bicycles, trains, cars, planes, calendars, clocks, etc. So, we will see some examples. Science and technology, mathematics used in engineering, artificial intelligence, space exploration, medicine, etc. So, everywhere mathematics is used. Then in engineering and architecture, structures like bridges, buildings, and vehicles rely on mathematical principles. So, to build bridges, buildings, vehicles, etc., mathematics is used. Some mathematical principles are involved. Then economics and finance, mathematical models used in market trends, then manage investments, etc. to analyze market trends, then investments, etc. we are using mathematical models. So, everywhere in science and technology, engineering, architecture, economics, finance, everywhere we are using mathematics. Patterns in numbers. Among the most basic patterns that occur in mathematics are patterns of numbers, particularly patterns of whole numbers. So, the most basic pattern in mathematics are patterns of numbers, especially whole numbers. What are called whole numbers? Whole numbers are numbers starting from 0 and go on infinitely. 0, 1, 2, 3, 4, etc. Then what are called natural numbers? Natural numbers are counting numbers. They start from 1, then go on infinitely. 1, 2, 3, 4, 5, etc. The branch of mathematics that studies patterns in whole numbers is called a number theory. So, what is number theory? It is a branch of mathematics that studies patterns in whole numbers. Whole numbers means 0, 1, 2, 3, 4, etc. up to infinity. Then, number sequences are the most basic and among the most fascinating types of patterns that mathematicians study. So, number sequences, they are the most interesting types of patterns that mathematicians study. Then, table 1 shows some key number sequences that are studied in mathematics. So, we will see some number sequences. We have given some examples of number sequences here. Then, some questions are given. Can you recognize the patterns in each of these sequences in table 1? Can you recognize a pattern? Here it is given that all ones, counting numbers, odd numbers, even numbers, triangular numbers, squares, cubes, then like this. So we will see everything we will see. Then next one, rewrite each sequence of table 1 in your notebook along with the next 3 numbers in each sequence. After each sequence, write in your own words what is the rule for forming the numbers in the sequence. These things we will do. First sequence 1 comma 1 comma 1 comma 1 comma etc. All ones. So what's the rule here? Each time 0 is added to get the next number. Each time 0 is added to get the next number. That is 1 plus 0 is equal to 1. Again 1 plus 0 is equal to 1. 1 plus 0 is equal to 1. So each time 0 is added to get the next number. So first number is 1. So 1 plus 0 is equal to 1. Again 1 plus 0 is equal to 1. So all ones. It's very easy. The next sequence 1, 2, 3, 4, 5, 6, 7, etc. They are counting numbers. What's the rule here? Each time 1 is added to get the next number. Each time 1 is added to get the next number. See, first number is 1. So, 1 plus 1 is equal to 2. Then again, 1 is added. 2 plus 1 is equal to 3. Then 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. So, 1, 2, 3, 4, 5, 6, 7 already given. Then next 3 numbers 8, 9, 10. 7 plus 1 is equal to 8. 8 plus 1 equal to 9. 9 plus 1 equal to 10. Okay. Next sequence 1, 3, 5, 7, 9, 11, 13, etc. So, this is a sequence of odd numbers. What's the rule? Each time 2 is added to get the next number. To get the next number, each time we add 2. See, first number is 1. So, 1 plus 2, 3. Again 2 is added. 3 plus 2, 5. Then 5 plus 2, 7. 7 plus 2, 9. 9 plus 2, 11. 11 plus 2, 13. So, up to 13 is given in the question. So, we have to find the next 3 numbers. So, 13 plus 2, 15. 15 plus 2, 17. 17 plus 2, 19. Okay. So, this is a sequence of odd numbers. We will see the next question. 2, 4, 6, 8, 10, 12, 14, etc. So, this is a sequence of even numbers. Even numbers. Even numbers, numbers ending with the digit 0, 2, 4, 6, 8. They are even numbers. Then, what is the rule used here? Each time 2 is added to get the next number. Each time we add 2 to get the next number. So, here first number is 2. So, 2 plus 2, 4. Then again 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. 10 plus 2, 12. 12 plus 2, 14. 14 plus 2, 16. Up to 14 is given in the question. So, remaining 3 numbers, 16, then 16 plus 2, 18, 18 plus 2, 20, 16, 18, 20. So, this is a sequence of even numbers. Next, we will see another sequence, 1, 3, 6, 10, 15, 21, 28. This is a triangular sequence of numbers. Triangular numbers. What do you mean by triangular numbers? Triangular numbers are a sequence of numbers that can be represented as dots arranged in equilateral triangles. So, they are sequence of numbers that can be represented as dots. These numbers can be represented as dots in an equilateral triangle. So, we can easily find the sequence using a formula. See, Tn is equal to n into n plus 1 by 2, where Tn is the nth triangular number. For example, first triangular number, second triangular number. Here, first triangular number is 1. Second triangular number 3. Third, 6. Fourth, 10. Then, fifth triangular number 15. Then, sixth triangular number 21. Seventh triangular number 28. Then, we have to find the next 3. So, we have to find the 8th triangular number, 9th triangular number, 10th triangular number. Okay, so using this formula we can find. Then what is n? N is the position of the number in the sequence. So, suppose we have to find the 8th triangular number, that is T8. Instead of n, you write 8. T8 is equal to n into n plus 1 by 2. Here, what is the value of n? 8. So, 8 into 8 plus 1 by 2. So, 8 into, what is 8 plus 1? 9. So, 8 into 9 by 2. What is 8 into 9? 72 by 2 is equal to 36. So, 8th triangular number is 36. So, we got 1, 36. Then, we have to find 9th triangular number and 10th triangular number. That we will do. We already got 8th triangular number. Then 9th triangular number is equal to T9 is equal to 9 into 9 plus 1 by 2. Formula is Tn is equal to n into n plus 1 by 2. Instead of n, you write 9. 9 into 9 plus 1 by 2. So, what is 9 plus 1? 10. So, 9 into 10 by 2. 9 to 10, 90 by 2. That is 45. So, 9th triangular number is 45. Then we have to find 10th triangular number, T10 is equal to 10 into 10 plus 1 by 2. That is 10 into, what is 10 plus 1? 11 by 2. 110 by 2. That is 55. So, 10th triangular number is 55. Okay, so you got the sequence. So, the sequence is 1, 3, 6, 10, 15, 21, 28, then 36, 45, 55. Okay. Next sequence, 1, 4, 9, 16, 25, 36, 49, etc. So, These are squares. See, what's the rule here? How do you get the first number? 1? 1 square. That is 1 into 1. 1 times 1. 1. Then 2 times 2. 4. Then 3 times 3. 9. 4 times 4. 16. 5 times 5. 25. 6 times 6. 36. 7 times 7. 49. Then we have to find the remaining 3 numbers. That is 8 times 8. 64. Then 9 times 9. 81. 10 times 10. 100. So these are squares. Okay. So next sequence is 1, 8, 27, 64, 125, 216. So these are cubes. What is the rule here? 1 cube is equal to 1 into 1 into 1. That is 1. So first number 1. How did you get? 1 into 1 into 1. 1 cube. The next number 8. How did you get? 2 cube. 2 into 2 into 2. That is 8. Then 27. How did you get? 3 cube. 3 into 3 into 3. Similarly, 64. 4 cube. 4 into 4 into 4. See, 5 cube is 125. 6 cube, 216. 7 cube, 343. 8 cube, 512. Then 9 cube is 729. So the sequence is 1, 8, 27, 64, 125, 216, 343, 512, 729. Next sequence 1, 1, 2, 3, 5, 8, 13, 21. Virahanga numbers or Fibonacci numbers. Then what's the rule here? Get each Fibonacci or Virahanga number by adding the previous two numbers. By adding the previous two numbers, we will get the next Fibonacci number. So, how did you get 2? By adding the previous two numbers. So, 1 plus 1, 2. Then, how did you get 5? 5 is just add the previous two numbers. So, 2 plus 3. Okay, 5. Then, how did you get 8? You add the previous two numbers. That is 5 plus 3, 8. Then, 13. How did you get? You just add the two previous numbers. 8 plus 5. It is 13. So, up to 21 is given. So, what's the next 3 numbers? What are the next 3 numbers? So, add 13 and 21. You will get 34. Then, 21 plus 34. You will get 55. Then, 34 plus 55. You will get 89. Okay. So, the series is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. Next sequence 1, 2, 4, 8, 16, 32, 64, etc. So, these are powers of 2. What's the rule? A power of 2 is a number that can be expressed as 2 raised to an integer power. See, 2 raised to 0 is equal to 1. That is the first number, 2 raised to 0. Then what is 2 raised to 1? It is 2. Then 2 raised to 2, 4. 4. 2 raised to 3, 8. 8. Then 2 raised to 4, 16. 16. Then 2 raised to 5, 32. Then 2 raised to 6, 64. Then next 3 numbers. What is 2 raised to 7? 128. Then 2 raised to 8, 256. Then 2 raised to 9, 512. 512. So the sequence is 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. These are powers of 2. Next, 1, 3, 9, 27, 81, 243, 729. This is a sequence of powers of 3. So what's the rule? A power of 3 is a number that can be expressed as 3 multiplied by itself a certain number of times. 3 multiplied by itself a certain number of times. See, what is 3 raised to 0? 1. See, any number raised to 0 is 1. Okay, so 3 raised to 0 is 1. 2 raised to 0 is 1. 5 raised to 0 is 1. That's the rule. So, 3 raised to 0 is 1. Then, next number is 3. How did you get? 3 raised to 1. Okay. Then, next number 3 square. 3 into 3. That is 9. Next is 27. How did you get? 3 cube. 3 into 3 into 3. 9 into 3, 27. 3 into 3 is 9. 9 into 3, 27. Then, next number 81. That is 3 raised to 4. So 3 raised to 4 is 81. 3 raised to 5, 243. 3 raised to 6, 729. 3 raised to 7, 2187. Then 3 raised to 8, 6561. 3 raised to 9, 19,683. So the sequence is 1, 3, 9, 27, 81, 243, 729, 2187, 6561, 19,683. So this is a sequence of powers of 3. Children, thank you very much. If you like this video, please like, share and subscribe. We will see in the next video. Children, I am posting videos of classics, science, social, English and maths. Please visit Rekha's Knowledge Hub. Thank you.